Welcome back, Cat 5 class. Today we're going to go over dimensioning. Okay, so we are in Chapter 7. I'm going to break up this lecture into two separate videos. This is one long lecture. So for this class session, we'll cover half of the lecture. So this will be part 1. And in a second video for the next class session, we'll have part 2. So Chapter 7 assignment will be done by hand. So hand sketching, no AutoCAD. Okay, Chapter 8, we will be dimensioning, adding measurements in AutoCAD. And if you're using an old textbook, maybe a textbook 5 years or older, this would be in Chapter 4. For the newer textbooks, this is Chapter 7. And I will provide you the assignment with the answer key so you can check your work before you submit it. And just a reminder, if you don't get a perfect score on your assignment, you can resubmit. And a reminder, when it comes to tests, for tests, you can only submit once. You cannot resubmit. Whatever score you get on the test, that's your final score for that test. All right, so let's move on to the next slide. Before I start the lecture, let me first show you part of the assignment. Okay, so the first few problems are going to be like problem 7-5, where on the left, we see this view that is dimensioned, and there's actually 5 mistakes. So you are to identify the mistakes on this view and then correctly dimension it over to the right side. So hopefully after this lecture and the second lecture, you'll be better able to dimension a view correctly or group of views. And dimensioning is not easy. It's going to take some practice before you become a good draftsperson. Okay, so it may be overwhelming at first. Take some practice. Okay, and also you are going to have problems where they'll give you two views. So problem 7-10 is made up of a bunch of partial views. So we'll have a top view, bottom view, and maybe a side view. And you are to correctly put dimensions where needed. So if a machine shop is going to make this part for you, they're going to ask you for dimensions. So hey, I need this dimension. So we're just going to use the letter X to say, hey, I need dimension X here, I need an overall dimension, I need a dimension from this wall to this wall, and so on. Okay, so you're going to do the same thing with the other views, whether it's 2 views or a group of 3 views. What dimensions do you need? So using the letter X, unless you want to measure the actual part with the ruler, whether you want to use millimeters or inches, or just simply use X. If you are labeling a diameter, for example, you have to use the diameter symbol and X for your measurement. If it's a radius, if it's round, then you want to use R for radius and X. So radius X, or radius 1 inch, or radius 5 millimeters, and so on. Okay, so I will provide you with the answer key so you can check your work before you submit it. All right, let's go on to the next slide. We're currently looking at a detailed drawing. This is a drawing of a single part. That's why it's referred to as a detailed drawing. By the end of the semester, we'll be providing complete detailed drawings with title block and border and notes, and also making it part of a larger package drawing that will include an assembly with multiple parts. For now, if you want to put a title block and border, that's optional. We're going to focus on dimensioning it on this chapter, chapter 7. So here we have a front view, side view, and some dimensions of what you would see in a detailed drawing. So let's learn how to dimension our detailed parts. Next slide. Okay, first of all, let's take a look at dimension. So a dimension will give you a measurement. It'll give you a measurement of a feature or a detail on the part. So here we have an overall length of 30 units. So if we look at a dimension, we have our dimension line, we have our arrowheads, we have the feature size, in this case an overall length of 30 millimeters or 30 units, and we have an extension line and gaps. So note the extension lines extend to the object lines, and we place a gap So as to not mix up an extension line with an object line. Notice how an extension line is about half the thickness of an object line. An object line is about 0.60 millimeters in thickness. A dimension line and an extension line are about 0.30, 0.35 millimeters in thickness. Okay, next slide. Okay, so here we have a knurled bushing. We have an overall diameter of 30 units. So diameter, 30 units. You can see it's cylindrical in shape. 30 units in diameter. And it's rounded off. On the edges, it's rounded off with a constant radius of 2 units. Notice we point to the arc with what's called a leader. A leader line, a straight, inclined, thin, solid line leading to a note or dimension value. So here we have an example of a dimension value. We have a leader pointing to the arc, giving us the radius that goes around the top and the bottom. The second leader is a note. It's telling us we have a knurled surface. Okay, so we have this rough area, this knurled surface, and it's referred to as a medium knurl. That's the note. You can either use a solid circle or no symbol at all at the end to point to an inside area of the part. Notice we don't use an arrow. You can use an arrowhead, but it just looks cleaner if you use either a solid circle or no symbol at all. Okay, and again, notice it's angled, it's inclined, it's not horizontal, nor are these leaders vertical. Always try and give it an angle, maybe about 45 degrees, 30 degrees, 60 degrees, but avoid using horizontal or vertical leaders. Next slide. Okay, when using leaders, one thing you don't want to do is cross leaders. So from the previous example, we had a radius, for example, a radius of 2 units. And when you're pointing to the knurled surface, one thing you do not want to do is cross leaders. So earlier we were looking at a medium knurled surface. Okay, so avoid crossing leaders. Typically you have plenty of space to place leaders and avoid crossing them. There are some situations where you have a lot of information and you don't have a choice other than to cross them. But try and avoid crossing leaders. Avoid using long leaders. So one thing you don't want is to have a leader going all the way across to point something on the right hand side, for example. It's easier if you just come in from the right side and point with a short leader. But there are examples where you do have to use a long leader when the right hand side of a drawing is taken up by other leaders or dimensions, and you are forced to use a long leader, but try and avoid using long leaders. Leaders that are parallel to adjacent dimension, extension, or section lines. So again, try and avoid using horizontal or vertical leaders so as to not be mixed up with dimensions and extension lines. Avoid using small angles between the leader and the terminating surface. So again, try and use angles of 45, 35, 60 degrees, for example. Try and use like about a 45 or 30 degree angle or a 60 degree angle. But avoid using vertical or horizontal leaders or close to horizontal or close to vertical. Again, try and use a 60 degree angle, a 45 degree angle, or 30 degree angle. It doesn't have to be exact, just eyeball it so as to not mix them up with extension lines of dimension lines. Okay, next slide. Okay, so here we have a feature size of 20. Let's say it's an overall height of 20 units. Typically, you want to keep the arrowheads and the dimension size feature of 20 here between the extension lines of the dimension. But when you don't have room, like on the next example, you can take the text out, or in this case, the size feature of 10. We can leave the 10 inside and between the arrowheads, but it's going to look crowded. It's okay if you leave the 10 inside, but it just looks cleaner if you pull the 10 outside the extension lines. You can also take out the arrowheads instead, as shown on the next example. So another option is to leave the text inside. So here we have a dimension of 5. And if you have the arrowheads inside, it will look too crowded. So you have the option of placing the arrowheads outside the extension lines. And if it still looks too crowded, you can also take the text of 5 outside, just like we did with the 10 on this one. Okay, so once again, avoid having crowded symbols and text. And one way is to place them on the outside. Next slide. Okay, so let's take a look at a typical detailed drawing, minus the title block and border. Okay, let's take a look at the front view. So here's what a typical detailed drawing looks like with dimensions. I want you to notice that it's okay if a leader crosses an object line, that's okay. Notice the difference in thickness. A leader is about 0.30 millimeters. An object line is about 0.60. Also notice that it's okay if an extension line crosses an object line. It's okay. It's acceptable. And again, notice the extension line is about 0.30 millimeters. Object line is thicker at about 0.60 millimeters. Also note the gaps. You want gaps between the extension line and the vertex of the front view in this case. Here's another example of gaps. The gaps are about 1/32 of an inch. You want the gap to be visible, so as to, again, not to mix up an extension line with an object line. Okay, notice the gaps here. We have an extension line, an angled dimension extension line, again, not touching the vertex of the object. Okay, another thing to note is, typically when you dimension, you want to dimension from one side. Notice how the left side of the object has more surface area than the right hand side. So we're going to dimension from left to right. So we come to the first feature, which is the center of the hole. Remember in the past we talked about green center lines, our center marks, anytime we see a hole or a semicircular feature. So this is for the machinist to locate that center point when drilling the hole. We have a horizontal dimension and we have a vertical dimension. Okay, notice in this case we're dimensioning from the base. The base has more surface area than the top, so we dimension from the bottom, dimensioning upward. For these dimensions, we're dimensioning from the left to right, 0.50 units. The next dimension is where the slope starts, where the chamfer starts. It's 0.75 from this surface to this point. And finally, we have the overall length of 150, 1.50 units. And notice how you go from small to large. Okay, and we'll talk more about this on the next slides. And we have an angle of 34 degrees. That's the angle of the chamfer here. And we have the gaps. Notice also the leader has an angle. It's not exactly, but it's about 45 degrees in angle. Avoid using a leader that's horizontal or vertical. Give it an angle so it stands out separate from the dimension lines. Also note that the arrowhead is pointing towards the center of the hole. Okay, let's take a look on the right-hand side view. Here the bottom surface has more area than the top, so we're dimensioning from the bottom to top, 0.25, and then 125 overall. And in this case, the right-hand side has more surface area than the left, so we're going to dimension from right to left, 1 unit, and from right to left, 125 for the overall length. And always present your drawing, again, like presenting your new apartment to your friends and family. You're having a housewarming party. You want things to look presentable, space things out evenly with your furniture. Okay, so next slide. Dimensioning symbols. Okay, first let me mention that in the past, we didn't use that much symbols. We actually used to use the words. So if you go back to the 50s, 60s, 70s, or even a lot earlier, you're going to see, for example, diameter written out, or DIAM, short for diameter. 1.00 inches, for example, for the size of a circular hole. Nowadays, we're using more symbols, not only here in America, but internationally. The standards are using more and more symbols to avoid using words. So if somebody overseas is looking at your drawing, speaks a different language, it's easier for them to recognize symbols than to try and translate the words. Okay, so let's take a look at the first one, diameter. So here's a good example, a circular hole or a cylindrical shape. We're going to use the diameter symbol to describe its feature size, in this case a circular size. If you're dealing with the sphere, we're going to go with spherical diameter. Good example is a trailer hitch, or something as simple as a ball. We're going to put a spherical diameter. If you're rounding off corners with the radius, for example, corners of a table, corners of your desk, we're going to use radius. Again, you tend to round off corners to avoid having sharp corners where somebody can bump into a sharp corner, or you can scratch a wall with a sharp corner. So we tend to round them off with nice arcs, and we dimension it with the R for radius. Now, if you're dealing with a sphere, for example, that's cut in half, or it's cut into a quarter size, then we're going to use spherical radius. Again, if you're dealing with a complete or close to complete sphere, we're going to use spherical diameter. But if you're dealing with a partial sphere, then we're going to use spherical radius. Okay, next is a reference dimension. So when a machinist or an inspector that's checking the part, making sure that the dimensions are correct, when they see a dimension in parentheses, that just tells them, hey, it's just a reference dimension. Do not check this dimension when checking the part. It's just a reference only. Here we have the counterbore symbol. Counterbore symbol, that's when you drill a hole. You drill a hole, typically all the way through a piece of wood or aluminum. And you come in with a second drill with a larger diameter. And you drill, but it doesn't go all the way through. It's just a partial. As far as depth, it doesn't go all the way through. And you're creating a larger diameter hole over a smaller one. But the smaller one is longer, or it goes all the way through. We also have a countersunk. It's pretty basically a hole with a chamfer around it. And we'll look at more examples of these, of counterbore and countersunk holes, which are very common in manufacturing, aerospace, automotive. If you're dimensioning a hole, if we go back to the first symbol, diameter, if you have a hole that's 1 inch in diameter, but there's a pattern of 4 holes with the same size, then we're going to use 4x, telling us there's 4 of them. In an old drawing, you'll see 4 places. So if you have a pattern of 4 holes, let me go ahead and draw 4 holes with the same diameter. Instead of having to dimension each one individually, you can just say, hey, we have 4 holes here. So we're going to use 4x. And we can say diameter of 1. Okay, so 4x will tell us that we have 4 holes with a diameter of 1, so we don't have to dimension them separately. If you're looking at an old drawing, you would see diameter 1, and it would be 4 places. That was the old way of doing it. Again, they would call out diameter 1, 4 places. That's the old way of doing it. Now the new way is to just say 4x space diameter 1. It's just a lot cleaner and it takes up a lot less room. Next slide. Typically when you drill a hole, you typically go all the way through, but in some cases you don't want to go all the way through. So if you tell somebody to drill a hole but don't go all the way through, you're going to use the depth symbol. You can say, hey, we're only going a depth of 1 inch in this 2-inch thick aluminum block, for example. If there is no depth called out, then you can assume the hole goes all the way through the object. Okay, when a dimension is not to scale, you underline the dimension. If you're dealing with a squared shape, you can call it out as a squared shape. And you can say 2 inches, for example. So that indicates that all 4 sides are 2 inches in length. So it's giving you a squared shape. And obviously, since it's squared, it's going to have the same length for all 4 sides. Okay, the next dimension we're going to look at is, the next type of dimension is arc length. So the length along an arc. So here we have a length of 5, and it's an arc, so it's the length along the arc and not a straight line. You can also put the arc in front or behind the number. And I'll give you guys examples of arc length and depth. The other two, scale and square, we're not going to use in this chapter. Also, we're not going to use the following, but in some cases you're dealing with conic shapes. When you're dealing with conic locators, for example, when you have a cone fitting inside its opposite shape, we're going to use a conical taper symbol to dimension it. Next one, we have slope, which you see a lot in architecture. So you have a slope on the rooftop. You have a slope on the driveway, which you want to slope downward towards the street. So when it rains, you don't want the water to get inside your garage. So you have this slight slope going downward towards the street. And we're not going to be using these symbols in this chapter. Finally, we have symmetry. Now this is the symmetry symbol, which is common to see on drawings, but now, following the new standards, we leave out the symmetry symbol because when you have symmetry, it's obvious when you have left side is the opposite of the right hand side, they're mirror images. Because it's obvious, we leave out the symmetry symbol and instead we use a long green center line to represent symmetry. And we'll take a look at this on a later slide. Next slide. Okay, so this is what your homework is going to look like for chapter 7 by hand, or if you can do it digitally. We're not using AutoCAD in chapter 7. We'll be dimensioning in AutoCAD in the next chapter. Okay, so this is what you're typically going to see on your homework assignment. You're going to see a detailed view or a detailed drawing of an object that is dimensioned, but there's mistakes. So you are to look at the drawing and look for the mistakes. It takes practice. So if this doesn't make sense, I want you to come back later on and view this presentation a few times. It can be overwhelming learning how to dimension at first. It takes years to get good at it. Once you've created a few drawings, you get better and better at creating drawings. When you're first starting off, you don't know how to dimension a part. Okay, so let's take a look at this problem, something that you're going to see in your homework. Okay, so once again, anytime you dimension, you have to pick a side at what's referred to as a datum, and we'll talk more about datums in a later slide or on the next lecture. Okay, so the left side has more surface area than the right side, so we're going to dimension left to right. So we have 10 units, and then 50, again, we're dimensioning from left to right, and then the overall 60. We're dimensioning from left to right. Okay, so we have overall lengths. Now let's look at dimensions going vertically. Okay, so the base has more surface area than the top, so we're going to pick the base as our datum. And we're going to dimension from the bottom up. So we have 10 units for the first step. And again, from the bottom up, next step is 25 units. And finally, the overall height is 30 units. And we need to also locate the hole. Again, remember we talked about green center lines and green center marks. We need to locate the center of the hole so that the machinist knows where to drill. The machinist is going to aim for the center point when it comes to drilling a circular or cylindrical hole. Okay, so now that it's dimensioned, we need to point out some mistakes. So when you first create a drawing, you're first starting off, you have zero experience, and I was there 15 or more years ago, you're going to make mistakes. So luckily you'll have a checker or a supervisor to check your work and correct your mistakes. Okay, so one of the common mistakes when creating a drawing is spacing. So I want you to notice that here you have a lot of space between the object and the first dimension. And again, remember we start off with small dimensions and work our way up to the higher dimensions. Okay, so the first dimensions closer to the object should be the small ones, and you work your way up to the larger dimensions. Okay, so the first dimension, you do want it a certain distance from the object, and that distance is about 2 text heights. So the text height here should be about 0.16 or 0.18 inches. So you multiply that by 2, 1, 2, and that's how much space you want to have between the first dimension and the object. 2 text heights. So we have a text height. That's how much space you want to have between the object and the first dimension. Okay, now we have here a space, but here it's tight. The rule is, once you place your first dimension, from there on, you're going to put 1 text height between the first dimension and the next dimension, and so on. So that spacing is 1 text height, which is again 0.16 or 0.18 inches. So the spacing between the 10 and the 50 should be 1 text height. And the 50 units and the 60 units here are too tight together. You need to move the 60 outward or move the 50 downward to have a spacing of 1 text height, which is again about 0.16 or 0.18 inches. Okay, so that's our first mistake that we see. Okay, now let's take a look at extension lines. Remember, we need to have gaps. Again, gaps are about 1/32 of an inch spacing, depending on which standard you're using. Notice this one, there's no gap. So this extension line, there should be a gap here. Now notice this is one long extension line. We can actually place the 30 over here on this side to have a short extension line. But one rule about dimensioning is you try and group the dimensions together on one side. Either you want them on the right side or the left side. In this case, we chose to place them on the right hand side. These 3 dimensions on top, either you want them all on the bottom or all on top. You try and group them together. You try and avoid having lonely dimensions on one side by themselves. You want them together in groups. Okay, so we have this extension line where there's a gap missing. Same thing with this extension line, gap missing, and same thing with this extension line, gap missing. Okay, so another mistake that we see is avoid crowding or avoid crossing dimension lines with text. So this 10 here, we need to move it either downward or move it inside the arrowheads. Yeah, it'll look crowded, so it'll probably look better if we just move it down here or move the 25 and the 30 over further to the right to make room for the 10. And we're also missing a gap here at the bottom, which I missed. Another mistake that we see here is the 30. Notice how all the dimensions are in a horizontal position. This one is in a vertical position. So the 30 needs to be rotated 90 degrees. So it looks like 25. Now in old standards, especially architecture, this was acceptable. But nowadays aiming for horizontal dimensioning where the text is horizontally placed and not vertically as in the 30. Okay, another mistake that we see is avoid placing dimensions inside the object. If there was no room to place the dimensions outside, then it's acceptable to leave it inside. But we have room, so we're going to take this 30. We can either place it downward, but we want to group it with another group of dimensions, so we're going to take the 30 and move it up. And actually place it up here with the 10, 50, and 60. We tend to try to group dimensions together. Same thing with the 10. Now this 10 is the distance from the base to the center of the hole. Now this 10 has nothing to do with this 10. This is the height of this step, and this dimension is the location to the center of the hole. Now these two dimensions, even though they're the same of 10 units, they're not related to each other. So instead of taking this 10 over to the right, we're going to keep it separate and move it towards the left. Okay, so let's take a look at the next slide, which will identify all the mistakes, see if we got them all. Okay, let's review our mistakes. So the first mistake was spacing. Okay, so these are just too tight together. Okay, so we need to space them out further. We don't want it to look crowded. Also, another mistake that we saw is we try and avoid placing dimensions inside the object. We place them outside the object unless we don't have a choice where it's just too crowded on the outside with dimensions. Then it will be acceptable to place them inside. But in this case, we have room outside to move them. Okay, another mistake again is here we have text crossing each other. And we have text that is in the wrong orientation. We're also missing gaps, as we mentioned, between the extension line and the object line. And one thing that I did miss, I completely forgot, was the dimension of the hole, the circular hole. So we're missing the leader and the diameter of the hole. Okay, so let's take a look at the next slide of how it should look like once it's corrected. This part you don't have to do on your homework assignment, even though the instructions states to write down the mistakes and do it in writing. I want you guys to skip this part. Next slide. Okay, so this is what it should look like once it's corrected. So in your homework assignment, again, you don't need to write down the mistakes. Your job is to correctly dimension it. Take the incorrect dimension view and correctly rearrange the dimensions or add any dimensions that are missing. Okay, so let's take a look at the spacing. So notice the first dimension is about 2 text heights from the edge of the part. And then from there on is about 1 text height, 1 text height, 1 text height. Okay, notice how it goes from small, 10, 30, 50 to large, 60 units. And all the dimensions are from left to right because the left side has more surface area than the right side. Okay, same thing with these dimensions. We went from base to top because the base has more surface area. And again, we go from small dimension to large. And once again, the first dimension should be about 2 text heights away from the object. So here we're going in a different orientation, but we have a text height, and that's where you locate the first dimension. The next dimension from there on, you go 1 text height, 1 text height. And again, notice the orientation of the 30, same orientation as the others. Notice how the 10 was rearranged so it didn't cross the dimension line. So in this case, we could have placed the 10 inside like it's shown, or we could have placed it outside here on the bottom and left the arrowheads inside or leave them on the outside. Either one is correct. And again, the 10 for this step is separate from this 10 units. This 10 locates the center of the hole to the base. We want to keep them separate because the step has nothing to do with the location of the hole. This step can change to, let's say, 12 units, and the location of the hole would be a separate feature from the step, and it would have its own dimension, in this case 10 units. And again, If the arrowheads inside are just too tight, then place them outside, or you can place the text outside. And again, the one thing that I did miss from our earlier slide is the dimension for the hole. I want you to note that the leader always points towards the center of the hole, the circular hole. It always aims to the center. We have the arrowhead on the edge of the circle. We have a leader. Again, we try to aim for about 45 degrees. Here it looks at about 30 degrees with respect to the horizontal. And again, you're just eyeballing it. The leader doesn't have to be 30, 45, or 60 degrees. You just want something other than horizontal or vertical. And we have our diameter of 10 units. Now, one thing that you are allowed to do is cross extension lines. So this is acceptable. You can cross an extension line with an extension line. That's acceptable. Okay. You just cannot cross an extension line with a dimension line. So the dimension line has the arrowhead, but you can cross an extension with an extension, as we do here, 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 and there. It's okay to cross extension lines. It's okay for a leader to cross an object line, and it's okay for an extension line to cross the object line. Again, this extension line is showing us, hey, it's 30 units from the edge of the part, 30 units to the center of the hole, and it's 10 units from the base to the center of the hole. So this is something that you see on a drawing, the location of a hole. We dimension it to the center with respect to a horizontal and a vertical edge typically. Okay, so these are very common dimensions to locate a hole. Okay, next slide. Okay, here's another example of, again of what you're going to see on your homework assignment. So what are the 4 mistakes? Okay, so the first one that stands out is the center line. The center line should not go from one view to another view. These should be separate center lines. Okay, so we would create a center line and a separate center line, which represents the axis of the hole and the center of the circular hole. Okay, so now another mistake that stands out is the leader. Remember, we avoid trying to use leaders that are almost horizontal or vertical. We try and give it an angle of about 45, 30, or 60 degrees, and you're just eyeballing it. It doesn't have to be exact. Another thing, the arrowhead needs to point towards the center of the hole. Okay, another thing that's off with this drawing, once again, is the center line. So we're going to remove this portion of the center line. We're not allowed to cross a center line from one view to another. So we're going to replace it with an extension line. So we will replace this with a solid extension line. Again, we're not allowed to cross a dimension line. So a dimension line is the line with the arrowheads. It's okay if you cross extension lines. This is okay, but this is not okay. You do not want to cross an extension line with a dimension line. Either you can break the extension line, or we can just simply rearrange it, bring the 0.50 in and the 150 out. Another mistake here is this one unit here. Notice all the dimensions are inside, all the text for the dimensioning is inside the dimension line. Okay, so our numbers here need to go inside the dimension line, just like the others. This is okay here. It got crowded, so we took the arrowheads outward to make room for the text. Okay, so let's go ahead and take a look at the next slide. Okay, so the first mistake that we see is the leader. So the leader should not be horizontal or vertical. We want it to have an angle of 30, 45, or 60. And we want the arrowhead to point towards the center. So that's our first mistake. Okay, my next mistake was the center line. Okay, we don't want a long center line going from one view to another. And the text for the 1.00 units, it should be inside the dimension line. And we do not want to cross dimension lines. So the simple fix is to move the 0.50 in and the 150 out. Another thing I forgot to mention is you want to place dimensions between the views as to opposed as to having them on the outside. So the 0.62 diameter, we can actually place it over here to the right, but it's okay if you leave it here on the left. But we try and place dimensions between the views and not on the outside of the views. All right, so let's look at the corrected problem. One thing is, again, you don't have to, in words, point out what was wrong. You can just simply show the results, as we'll see on the next slide. So here is the corrected drawing. Once again, we want a leader that's not horizontal or vertical. Give it an angle. Again, it's okay if you place it over here on the right-hand side. There's plenty of room. And once again, we want to go from small to large dimensions. Small to large, 0.50 to 1.00. Same thing with these two dimensions. We want the 0.50 first, it's smaller, and then the 150. And that'll avoid crossing the dimension line as it did on the previous slide. Now we do want to place dimensions in groups. For example, we would want to put this 1.00 between the 0.50 and the 150 and group them together. But we're not allowed to dimension a hidden feature. Here the dashed lines and the center line represent the hole going all the way through this wall. But we don't dimension hidden features. We want to actually dimension the object, right? What we actually see. The hidden lines here we cannot see unless we turn on our X-ray vision. So we place the 1.00 dimension on this view. It's just a lot clearer what it's showing. It's showing us the location of the center of the hole. So this hole is located 1 inch from the base and 0.75 from the left-hand side. Okay, and again, another thing is you want to put dimensions inside between the two views. Avoid placing them on the outside. Sometimes it does make sense to put it on the outside, but the rule is to try and keep them together inside between the views. Okay, and again, the long green center line. Notice we have a short green center line and a short green center line and not that long green center line, which is not permitted. Instead, we use an extension line to replace it. Okay, so next slide. Okay, so here's a more complicated problem. We have 3 views now. I want you to note that one thing that is correct is we have the top view, front view, and dimensions in between them. We have the front view, side view, and dimensions in between them. And another thing that does look right is we try and group dimensions together, right? We try and avoid having dimensions by themselves, like the one here. Sometimes you don't have a choice. Okay, so for this exercise is find duplicate dimensions. When you first start off as a drafter, a very common mistake, and we all make them, is to over dimension. Put too many dimensions. That's a very common mistake. When somebody asks you for directions to the nearest McDonald's, for example, keep it simple. Go to the next slide, make a right, 3 blocks down, you'll see McDonald's on your left-hand side. Keep it simple, don't give more than what they need. Same thing with the drawing. When you give this to a machine shop to make the part for you, to machine it for you, you give them the minimum amount of dimensions. If you give them too many dimensions and the dimensions are in conflict with each other, then it's just going to create confusion and it's going to make the part more expensive and it's going to slow down your deadline and it'll cost you more money. Okay, so there's some duplicate dimensions on this drawing, and let's take a look at the next slide and decide which one we're going to eliminate. Okay, so The first duplicate dimension that we see is the 40 and 40 here. They're both dimensioning the same feature, which is this wall thickness here. So the wall thickness is 40 units. And here we have it again. The wall thickness is 40 units. So this is considered double dimensioning. Again, this is a very common mistake when you're first starting off. You try and over dimension things. You try and provide too much information. In this case, we have duplicate dimensions. We need to eliminate one of them. Next slide. So the dimension of 40 is a duplicate. So we need to get rid of the one here on top. And the reason we get rid of the one on top in the top view is because it makes more sense to keep it in the right-hand side view, because we get to group it with the 135. Again, you try and group dimensions together with one another, and you try and avoid having lonely dimensions. So that's one reason to keep it on the right-hand side view. Another reason is because it's a lot clearer in the right-hand side view that we're dimensioning a wall thickness. On the top view, it's not very clear what we're dimensioning. It's just a lot more clear on the right-hand side view. Next slide. Okay, so now that we eliminated the 40, let's focus on the dimensions between the front and the top view. Okay, we do have some duplicates going on here. We have the 60 dimensioning this feature, which is the same as here. So there's 60 again. So we have two 60s. These are duplicate dimensions. We need to eliminate one. And also the 200s. They're dimensioning that same feature, 200 and 200. So we need to get rid of one of them. Okay, so now the decision is which ones do we get rid of? So you try and group dimensions together, right? So we can either keep the 60 and 200 on top, or we can group it with the 260. So it makes more sense to keep the ones in the front view, eliminate the ones on top, and that way we can group the 60, 200, and 260 all together as one large group. And again, you go from small to large, 60, 200, 260. And also notice the spacing between the 60 and the object. The first dimension is about 2 text heights away from the object. And then from there on, you'll have 1 text height in between the dimensions. Okay, now let's move on to the next slide. Okay, so now let's take a look at the dimensions between the front and side view. Okay, so do we see any duplicates? Yep, we see the 100 and the 100. They're both dimensioning that same height. Now, you can keep it on either side. The 135 would end up by itself if you eliminate the one on the right. If you keep the one on the left, it'll be part of a larger group. So here, either one is correct. It just makes more sense if you leave it here on the front view, because you can see it's measuring a height. We have 100 units from the base to this height. On the right-hand side view, the 100, yeah, it's measuring to this height that we see on the front view, but it's not clear that we're dealing with the height. So it's actually better to eliminate the one from the right-hand side view. It looks cleaner here. We have a group of 3 dimensions, and unfortunately, we're going to leave the 135 on its own. We can move the 135 over and make it part of the larger group, the 135, and place the dimension here. But then you're going to deal with a long extension line. And second, it's just a lot cleaner to leave the 135 here where we're actually measuring a height. So we'll leave the 135 alone. Next slide. Okay, so what have we learned so far when it comes to placing dimensions? A, dimensions should be grouped whenever possible. So you want to group dimensions together and avoid having lonely dimensions all by themselves. B, dimensions should be placed between views. So if you go back to the previous slides, you saw that the dimensions were placed between the front and top view and between the front and side view. Avoid having them outside the views unless clearness is promoted by placing some outside. Okay, C, dimensions should be attached to the view where the shape is shown best. So just like we did with the previous slide, when it's clear that you're dimensioning a height, then you want it in that view where it clearly shows that we're dimensioning height. Or like we saw with the 40, we saw that it was dimensioning a wall thickness. Okay, so place the dimension where it makes more sense when you're dealing with duplicate dimensions. Place it where it makes a lot more sense, where it gives clarity. D, do not dimension hidden lines. So just like the hole, when we dimension the location of a hole, we dimension to the center. You do not want to dimension the hidden hole. You want to dimension the shown circular hole, where it's actually seen as an object line. And E, avoid long extension lines. You can notice it says avoid. Sometimes you can't help it. Sometimes you do need to place that long extension line, but try and avoid them. Next slide. Okay, so as we learned on the previous slide of dimension placement, you try and place dimensions in between the views. So here we have these dimensions. You try and place them between the views, top view, front view, as opposed to having this dimension of 60 by itself on the outside. Can you try and place dimensions between the views if possible? It does make more sense sometimes to place them on the outside, but try and avoid placing them on the outside. Okay, so let's take a look at the 6 mistakes. Next slide. Okay, so let's take a look at the first mistake. Again, you try and place dimensions between the views. Here we have a dimension on the outside. It's okay if you leave it on the outside. It just looks better if you bring it in and group it with the other dimensions, and it's between the front and top view. Okay, another mistake here is this leader. It's okay if you leave the leader here. It just looks better when it's floating upward and the arrowhead pointing downward. We try and avoid having arrowheads pointing outward when it comes to a leader. We typically want the leader and the text to be floating upward and pointing down, right? A leader feels like a leader and they want to point downward on the people below them, right? Here the leader's pointing upward. We want to show that the leader is superior by placing it upward and pointing down. Okay, let's take a look at another mistake. You don't dimension hidden lines. So from one of the previous slides, we did learn that we avoid dimensioning to hidden lines or hidden features. So here the 5 units is dimensioning to a dashed line, a hidden line. You try and avoid that. If you don't have a choice, then you leave it. But here we do have a choice. It's dimensioning the depth of the slot. So this hidden line lines up with the slot. So we're going to bring this 5 down here. Yes, it's going to be lonely. It's not going to be part of the group, but it just looks cleaner, dimensioning the feature that we can physically see as an object line versus a hidden line that we cannot see unless we turn on our X-ray vision. Okay, let's take a look at the next mistake. Okay, the 25. One of the rules is to place dimensions where the feature is shown best. Okay, so what's wrong with this 25? What's wrong with dimensioning this line? Well, we see the object line, but we don't see what it's doing. It's a lot clearer here in the front view. Oh, it's the thickness of this wall, right? Or it's the dimension to this next step. So the 25 looks cleaner here in the front view, where it's clear that it's given us a wall thickness or a distance to the next step. Same thing here with the 10. The dimension of 10 is dimensioning to this object line, but it's not clear what this is doing here. But here in the front view, it's clear. It's a step, right? Or you can see it as the thickness of the step. So this 10 looks better if you place it here. And you get to group it with the 20. Okay, let's take a look at the next mistake. Now we try and group dimensions together, right? So that's one of the rules. We try and group them. We can either bring the 15 here, but then we would be dimensioning the 15 to a hidden feature here, which we don't want to do. The 15 is dimensioning to the center of the hole Here is that center axis of that hole, and we don't want to place the 15 to a hidden feature. That's one of the rules. Avoid dimensioning a hidden feature if you can, and we can do that by leaving it here at the 15. So we're going to have to move the 30 over. The depth here of 30 is the same depth as here. It's the same depth that we're looking at. So bring the 30 to the 15 and group them together. Okay. And another mistake that we see here is this long extension line. Now we try and place dimensions in between the views, but it just doesn't look right having this long extension line when we can just avoid it by taking the 20 units and placing it on the outside. Again, you try and avoid having dimensions on the outside, but the 20 just looks better by avoiding having this long extension line. We can just place it here on the left. Same thing with the 10 units. To avoid having long extension lines by placing it in between the views, it's better to place it outside. The 35, you can leave it here, or you can bring it inside. And yeah, you'll be dealing with the long extension lines. So you get to pick either having a long extension line with the 35 or placing it with the two other dimensions and grouping it. Either way, the 35 can stay out here on the outside or bring it in. Either one is fine. Next. Okay, so here we have the drawing correctly dimensioned with proper dimension placement. And the first one was the leader. Okay, remember earlier we had the leader down here with the text floating down towards the right. It looks cleaner if you place it on top with the text floating upward and the leader pointing down. So think of it as saying I'm the leader and I'm pointing downward towards you as opposed to pointing up. Okay, it's okay again if you leave it down here. It just looks cleaner if the leader is pointing downward and the text floating upward. Okay, another mistake that we saw was the 30. Yes, it's okay if you leave the 30 here on the side view. It just looks cleaner when you group it with the 15. The 15, it's important to keep it in the top view because it's dimensioning to the center of the hole, just like the 45. You want to keep the 45 and the 15 in the top view because we can physically see the circular hole. Okay, another thing is, again, we want to keep dimensions between the views and we try and group them together. The 45 needs to stay because it's dimensioning to the center of this hole that we can physically see. We would not put the 45 down here, dimensioning a hidden feature. We leave it where we can actually see the feature. Earlier we had the 5 units dimensioning the hidden line. Again, we avoid dimensioning a hidden feature. Here we can see it in the front view that it's a slot. So it's better to bring the 5 down to the front view where we can clearly see we're dimensioning the depth of the slot. The 25, instead of placing it up here, looks cleaner in the front view because we can see it's dimensioning to the next step, or you can say the thickness of the wall. The 20 was in between the views as it should be, but it had that long extension line. So it's better to keep the 20 on the outside of the view versus in between the views. And same thing with the 10. The 10 units was in the right side view, but it looks clearer here in the front view, which is dimensioning the thickness or the height of the step. Now the 35, we could have left the 35 on the outside and group it with the other two to avoid this extension line. You can make the argument, hey, we're trying to keep it in between the views and avoid this extension line. We can always place it outside. So either way, it's fine. You can keep the 35 in between the views or, in this case, outside. Okay, now remember we dimension from, in this case, bottom up. The base has more surface area than the top, so we're dimensioning from the bottom up to 10, that step. Also bottom up to the height of 35, bottom to the slot. But hey, you can make the argument, teacher, how come we don't have a dimension of 30 instead of 10? We could have placed a dimension of 30 instead of 10. We could have placed a dimension of 30 here. if we're following the rule of dimensioning from a datum, in this case the base. So again, we're supposed to dimension bottom to top, bottom to top, bottom to top, bottom to the top of the slot. Now the reason we're not using the 30 and instead we're using the 10, it's because most likely something has to fit inside this slot and the 10 has priority over the 30. If there was nothing going inside the slot, then we would use 30 instead of 10. But by dimensioning the slot with the 10 units, that's telling the machinist or the inspector that most likely something's gonna fit inside this slot. Okay, so that's the reason for the 10 instead of using a dimension of 30. Okay, so now let's go on to the next one. Okay, so when it comes to dimensioning a circle or close to a complete circle, you want to use diameter. Notice how the leader is floating upward with its text floating upward and the arrowhead pointing down and towards the center of the hole. If it's in an incomplete circle, like a semicircle, again, here we have a 180-degree angle circle, or even if you're just dealing with a 90-degree circle. In this case, we have partial circle, referred to as an arc. Then we don't use diameter, we use radius. Okay, so R is for radius. Notice the text is floating upward, leader pointing downward with the arrowhead always pointing towards the center. Next slide. Okay, let's take a look at circular views versus rectangular views. So as you can see on top, we have the circular view because we can see circles. And in the front view, this is referred to as a rectangular view because the cylinder in the front view looks rectangular in shape even though it's cylindrical. Same thing with the hole. Here the view looks rectangular even though it's a hidden feature. We draw it as rectangular even though it's circular, but from this perspective it looks rectangular. But if you look at it from the top view, the cylinder and the hole will look circular. So that's why this is referred to as a circular view. Okay, one rule when it comes to dimensioning a cylinder versus a circular hole. So when you dimension a cylindrical shape, a cylindrical solid, you do not dimension the circle, you dimension the rectangular view. So when you see here the diameter 20 of this rectangular view, which is actually the cylinder, it's letting us know that, hey, we're dimensioning a solid. And it's a cylindrical shape, diameter of 20. Now, if you're dimensioning a hole, which is circular, cylindrical shape, but it's a hole, then you dimension the circle. So we do it in the circular view. So again, when you're dimensioning a circular hole, you dimension it in the circular view. If you're dimensioning a solid cylindrical shape, you dimension it in the rectangular view. And the reason this is done is just in case you don't have this isometric view that we see here on the left. If all we have is a front and top view, an experienced drafter, an inspector, a machinist, when they see this diameter 20 dimension on a rectangular view, right away they know, oh, this is a cylinder. When they see a circle dimension with the diameter, that tells them, oh, it's a hole. So this is obviously is a hole. This here is a cylinder. This rarely comes up, but once in a while you will encounter this type of rule to follow. Okay, next slide. Okay, let's talk about depth. The depth of a blind hole may be specified in a note and is the depth of the full diameter from the surface of the object. Okay, let's take a look at this side view. So when you take a drill through a piece of wood, aluminum, or steel, for example, if you don't drill all the way through and you need to stop at a certain point, we need to call out that depth. Now, even though the drill goes beyond, those of you that have ever used a drill know that the tip of the drill is conic in shape, is a V shape, because it makes it easier to drill. It's not flat at the end, it's pointy at the end, allowing us to drill a lot easier and scooping the material out as it's drilling through. Okay, so the depth is not to the tip where it ends, it's actually where the cylindrical shape ends. Even though here this is referred to as a rectangular view, this is cylindrical. So it's dimension from the surface where you break through and where the cylinder shape ends. That's the depth. We really don't care what happens beyond that point. Okay, so depth, we use the downward arrow, as you see here. So here we have a diameter of 10 units. Okay, so the diameter is measured from one quadrant to another. That's the diameter, or from this quadrant to this quadrant. So it's the measurement across a circle, and you go through the center point and go across. So that's 10 units. So this is 10 units in diameter, and it ends here. And we have the depth of 15th of the cylindrical shape. So this indicates the depth of 15 units. Now, if you call out a hole, a circular hole, and there is no depth shown on the dimension, then you assume that the hole goes all the way through the material. Okay, so that's one of the things you are allowed to assume is if you're not given the depth of the hole, you assume it goes all the way through. Another option is to say diameter 10 and write the word through, T-H-R-U. But that's an old, that's something that was done decades ago. It's something that is not used nowadays. In the last few decades, we've gotten away from using words. Next slide. Okay, typically when we create a radius, for example, on a corner of a table, we do not dimension to the center of it. Typically, we round off corners of a table, for example, or a desk to avoid having sharp corners. So a radius is more than enough, and we assume tangency with the straight line. But in some cases, you do need to dimension to the center of an arc, a radius, or also referred to as a fillet. Typically, that's done when the location is important. Again, for a table, rounding off the corners, making them round, the location is not important. It's just to avoid having sharp corners. But when you do a dimension to a center of an arc, which is very rare, it's typically when it has to mate up with another piece. Maybe there's another piece over here that it mates up to, and it's the opposite shape. It's opposite. Or at an assembly level, the location is important to avoid maybe hitting something. Or once again, it's to also to mate with another part. So this is the way you dimension it, and you do it with a simple center mark. In this case, you do not extend. Again, this is a very rare situation, but it does exist. Next slide. Okay, here's what's more common when it comes to a fillet, a radius, arc. Okay, where the center location of the radius is unimportant, the drawing must clearly show that the arc location is controlled by other dimension features such as tangent surfaces. Okay, so this is what you typically see most of the time. So for example, the corner of a table, right? You round it off to avoid having a sharp corner where somebody bumps themselves into and creates a bruise or a cut. Okay, so you round it off, and we assume tangency with the straight line. So this is what you typically see with a round corner, also referred to as a fillet or an arc. And it doesn't matter if you place the arrowhead on the outside or the inside. It's typically placed on the outside, but it may also be placed on the inside. Notice how the text is floating outward. That's what you prefer. Also, when you have an inside fillet, an inside radius, same thing, you assume tangency with the vertical and horizontal line. Again, the location of these arcs are not important, so we do not use little center marks to locate the center of the arc. We're just rounding off the corner to avoid sharp edges or to give it a more stiffness. And we simply do it by just calling out the radius. Okay, same thing on the first one here. We have an arc where the center is not important. and we can assume tangency, and all we need to do is dimension the radius of the arc, and you can place the arrowhead on the inside or the outside. Next slide. Okay, a complete sphere is dimensioned by its diameter, and an incomplete sphere is measured by its radius. Okay, so one simple example is if you play pool, the spherical balls, right? You dimension it with a spherical diameter. So here we have a spherical diameter of 40 units, measuring all the way across. When you have a partial sphere, like the tip of a pool stick, right? That's a partial sphere. Then we don't use diameter, we use spherical radius. Okay, so that's the difference. When you're dealing with the complete sphere or something close to a complete sphere like a trailer hitch ball, then you use spherical diameter. When you're dealing with a partial sphere, then you use spherical radius. Next slide. Okay, so here we have a front view of a circular shape and the right side view, which is referred to as the rectangular view. Okay, let's take a look at how we dimension circular features or holes. So here we have holes on a circular pattern. So let's take a look at the next slide. Okay, let's take a look at the hole. So we have 4 holes with the same diameter. So that's why we use 4x, indicating that there are 4 holes. 4 times, or 4x, space, diameter of 8. So all 4 holes have a diameter of 8 units. And the 4 holes lie on a circular pattern. So we draw this imaginary center line. So if we were doing AutoCAD, this would be a green center line, indicating that these holes lie on this imaginary circular pattern, or I should say this imaginary line. Okay, so this imaginary center line, this green center line, if it was AutoCAD, we would dimension it, and it has a diameter of 40. Now, we don't physically see this line. It's an imaginary center line, but that's to show us that the 4 holes lie on a circular pattern of a diameter of 40 units. Okay, also here we have the spacing of the holes are at 90 degrees. Okay, so we have 360 degrees total, and the spacing is 90 degrees. So instead of having to dimension 90 degrees 4 times, we do it with one 90-degree angle. 4x tells us that there's 4 angles. So 4x space 90 degrees. Okay, so we only have to do it once, just like we did with the diameter of 8. We don't want to have diameter of 8 4 different times. We just call out diameter of 8 once. 4x telling us it's in 4 places. Okay, so now let's take a look at diameter 60. So diameter of this cylindrical shape is 60. Now because it's a solid cylinder, we do not dimension the circle. Remember the rule that we learned on one of the previous slides? If it's a circular, solid, cylindrical shape, we don't dimension the circle, we dimension the rectangular view. So that's the reason for the 60 here. The 60 here tells us it's a cylindrical shape in the rectangular view. Same thing with this circle. This circle here is not a hole. The circle is a cylindrical solid. It's a shaft, and we dimension it in the rectangular view. So we have it here at diameter 20. Again, we do not dimension this circle of diameter 20 because it's a solid. Now, if it was a hole, if this circle represents a hole, then we would dimension the circle. The diameter 8 circles here are holes, so that's the reason we do dimension the circle, because they're cylindrical holes. But the other circles represent solids, so we dimension it in the rectangular views. And these are the dimensions of the depth, or I should say the thickness or the heights of the cylinders. The first large cylinder of 60 units in diameter is 10 units, and from the base to the height of the smaller cylinder is 30 units. Okay, and again, avoid dimensioning hidden features. Notice we're not dimensioning the hidden features here, which represent the holes. We do it in the view that it's shown as physical items. Next slide. Okay, in this example, we're looking at an arc with the radius of 98. Now this arc, the location, its center, it's important. The problem is that the center of the arc falls off the sheet. So it falls off the sheet. So one way to get around that is by using what's called a jog dimension. So we're faking the center. So the center of that arc is not here. It's actually somewhere down here outside of the page. So what we do is we create a jog dimension to indicate, hey, this is not the real center. This is a false center. But here are the dimensions, 14. So 14 is an actual dimension horizontally, 14 units. So the center is actually somewhere down here at 56 units. So from this horizontal line going downward, it's 56 units going downward. And we can see it by the jogged dimension. Okay, this is rare, but you do encounter it once in a while. Next slide. Okay, so here we have a solid. So first we have a rectangular base with this racetrack shape, which is a solid sticking outward. Now this solid most likely has to mate up with another piece with its opposite, which has the same shape, except it'll be a slot, it'll be a hole, and this will most likely mate up with it. Okay, so in this case, we're not going to measure center to center. We're not going to go center to center. We're going to dimension edge to edge, quadrant to quadrant. Okay, so that's what we have shown here. The overall length of the solid is 40 units. And the width is 10 units. And we call out the radius. Okay, so just imagine it first starts off as a rectangular shape, and then you machine it with the radius. Now, what is the radius? Notice they don't give us the size of the radius. All you have to do is take half the size of 10, which is 5. So the radius is actually 5. Just take half of 10. Now, the reason they don't give us 5 and instead give us 10 is because they're telling us that this width is more important than the radius. So here we have a width of 10, overall length of 40. And by dimensioning it this way, most likely it has to fit inside of its opposite shape, a slot, a hole, or elongated hole. It has to match up like a puzzle. And the dimensions, the overall dimension and the width are a lot more important than the radius. So that's the reason we don't dimension to the center of the radius or call out a radius. The overall length and width are more important. Okay, sometimes you will also encounter this type of solid where it's not a tangent radius. Same thing here. If it wasn't a complete radius with tangency, most likely again this would have to fit inside something else. So we want to give the overall length, quadrant to quadrant, in this case 34, and a depth of 10. Yes, we do have a radius here. That's called out 7 and not 5 like on the previous one. This would be 5. This one has a different radius of 7. And the reason it has a different radius is because there's no tangency like in the first one. We do have tangency. So all we have to do is take half of 10, which will give us a radius of 5. Here, we don't have a radius of 5, and that's the reason we don't have tangency. Okay, we're not going to be covering this in chapter 7. I just wanted you to be aware of it. Next slide. Okay, so here we have the slot, which is the opposite shape of the previous slide. So this is the mating part. So if the previous part that we saw on the last slide, if it was to mate up with this one, then we would dimension it as shown on the first one here. We would place overall dimensions quadrant to quadrant. So if the previous one was 40, this would probably be more like 40.001, so it could fit inside. We want this to be able to fit. So this hole will either be the perfect size or just slightly larger than the solid on the previous part. Now that's an overall length of 40, a depth of 10, and the radius of 5. Now, even though we don't see the 5, we know it's just half of 10. Half of 10 is 5. The reason we leave out the 5 is because then you would be double dimensioning. The 10 and the 5, if you just go, hey, radius 5 gives us 10, then you're double dimensioning. If you can calculate the number, then you leave it out. So we can calculate this to be 5. So we leave it out. It's just half of 10 is 5. From center to a point on the arc is 5. So even though we know the radius, we leave it out, or else we would be double dimensioning. Now, if this slot was accommodating a bolt, so sometimes you want a plate like this to slide back and forth, and then you tighten it down with a bolt, then we would use the second form of dimensioning. Then we would dimension center to center instead of overall. Again, you want to use overall when it's going to mate up with its opposite. In this case, we're not mating up with its opposite, so the overall length is not important. We just go center to center. The depth is 10. And again, because we can calculate the radius of 5, 5 is just half of 10. And then we leave out the 5 because it can be calculated. If you were to place the 5 in here, then you would be double dimensioning, which is not allowed. And we have the 2x telling us 2 places. So 2x, we have a radius with the same dimension, 5, and space. Okay, next slide. Okay, so let's take a look at arc length. This is not an angle. This is not an angle of 39 degrees. This is an actual length of 39 units. So it's not the dimension from corner to corner or vertex to vertex. It's the dimension along the arc. So if you were to take a ruler and measure along the arc, it would have a dimension of 39 units, let's say 39 millimeters along the arc. Now obviously the straight dimension would be something smaller than 39. I don't know, maybe something like 38 if it was measured straight corner to corner. But because we have an arc over the 39, it's telling us it's the length along the arc. And it's not an angle, it's an actual length. Okay, you can place the arc on top or you can place it in front. Either way is correct. Next slide. Okay, so here we have a hole pattern. So imagine you have a bar of aluminum and it has 11 holes. So there's a total of 10 spaces. So 11 holes and there's 10 spaces, 1, 2, 3, 4, and so on, 10 spaces. Now they're telling us that this pattern is not going to match up with another pattern. So these are holes where as a pattern, it's not important. I can tell by the way it's dimensioned. They're telling us, hey, we want to space these holes out by 15 units, let's say 15 millimeters. The overall pattern is not important. We just want a spacing of about 15. So 10 spaces, 1, 2, 3, and so on. Now the overall dimension from the center of the first hole to the last hole is 150. We know because it's 10 spaces times 15 will give us 150, but notice it's in parentheses. Since it's in parentheses, it tells the machinist or the inspector checking the part, hey, it's an overall of 150, but do not dimension this. Do not measure this. It's not important because it's in parentheses. Same thing with the 15 here. This is a reference only. They're telling us, hey, do not use this dimension. We're going to use this dimension. We have 10 spaces, 10x, space of 15 millimeters. So 15, 15, 15, and so on is the spacing between the holes. This would be double dimensioning. So to avoid double dimensioning with the 15s, we place one of them in parentheses. So this is referred to as a reference dimension. This is the one we're going to use. Next slide. So once again, here we have, let's say, a piece of aluminum with an arc shape. And we have 6 spaces, 7 holes. 1, 2, 3, 4, 5, 6, 7 holes. and 6 spaces in between them. 1, 2, 3, 4, 5, 6 spaces in between the whole pattern. And notice we have 6x telling us there's 6 spaces as we counted. Space 15 degrees. So the spacing is 15 degrees. The overall spacing of the pattern is 90 degrees. 6 times 15 is 90. So the angle from this center line to this center line, the overall is 90 degrees. But notice it's in parentheses. It's telling the machinist or the inspector, do not measure this. It's just reference only. We do not need to inspect to this. This is just so you know for a sanity check that this is 90 degrees. The important dimension is that we have 15 degrees in between the holes. 15 degrees, 15 degrees, 15 degrees, 15 degrees, 15 degrees, 15 degrees. Next slide. Okay, so let's talk about symmetry. So the left side is a mirror image of the right-hand side. So in the past, we would draw a center line to indicate symmetry and then draw the symmetry symbol. In the new standards, not all companies are using the latest standards. Typically every 10 years the standards are updated. Okay, so in the latest standards, the symmetry symbol is left out because it's just obvious that this is symmetrical, and all we simply need is a line of symmetry, and we can just leave out the symmetry symbols. Okay, so when you're dealing with a symmetrical part, one of the things that you can do is dimension half the object, as shown here, 20, 30. You don't have to go 20, 30 again. So to avoid having to dimension twice, because it's symmetrical, all you have to do is dimension half of it. Okay, and here we have a radius of 40. Again, because it's not a complete circle, we go with radius. When it's a complete circle, we go with diameter. And here we have the vertical dimensions. Again, we could have picked the top, which has more surface area. Here they chose to go with the base. Most likely this item mounts onto another piece, so they chose to make this the important datum instead of dimensioning from top to bottom. They chose to go bottom to top. Bottom to top, 10 units. Bottom to center, 20. Bottom to top, 30. Again, notice how it's in order, small to large. You have more spacing between the object and the first dimension line, and one text item between the remaining dimensions. Note again how we have the floating text when it comes to a leader. Floating text. Sometimes you don't have a choice and you have to aim from the downward pointing up, but since we have plenty of space, we want the text of a leader to be floating upward and the arrowheads pointing downward. And it has to either point towards the center or the leader has to go through the center. Okay, either one is correct. This is the end of the lecture. We will finish the lecture on the next lesson for chapter 7, but you have enough to complete your assignment. Your assignment will be to correct the dimension drawing. You don't have to explain what you did, just go ahead and dimension it correctly, and I will provide you with the answer key. End of presentation.